Welcome back. Today we're going to talk about arcs and chords. And arcs and chords are all things that have to do with circles, as we've been discussing in this chapter. And so when we talk about these arcs, we have big ones and small ones. Well, a minor arc would be a smaller one, and a minor arc is what we get when we have an arc whose endpoints are on the interior of a central angle. Angle ABC is a central angle with measure x degrees. Well, now if we have this minor arc, and you notice that arc AC or AC with an arc over the top, arc AC is this red arc, and it's going to be equal to x degrees because it's equal to the measure of the central angle. So I'm going to put that in parentheses, the measure of the central angle. Okay? So that's a minor arc. A major arc is an arc whose points are on or in the interior, the exterior of a central angle. So notice I have this ABC. Angle ABC is a central angle. And as a central angle, it has all of the points of arc ADC on the outside. Okay, so the measure of arc ADC, notice I'm putting the ADC underneath an arc. It's a little arc because it's an arc. So the measure of ADC is equal to the whole circle, which is 360 degrees, minus x degrees, minus the minor arc that's on the inside. Okay, so it's really a little bit of a math problem that's understanding where this is coming from. Okay, semicircle. Not a surprise here. A semicircle has the endpoints of the arc on the diameter. So the arc spans halfway around, and so that's going to be semicircle equals 180 degrees. Okay, that's all there is to it. These are the three types of arcs. Either it's smaller than 180, bigger than 180, or equal to 180. That's all there is to it. Okay, now let's move on. Let's talk about a couple of different things. Adjacent arcs. Adjacent arcs are arcs that share a circle, so they're on the same circle, and they intersect at exactly one point. Exactly. Whoops. Exactly one point. So as you can see, RS and ST are adjacent arcs. So RS and ST are adjacent. Okay, they're adjacent arcs because they share exactly one point. Congruent arcs. Congruent arcs are two arcs that have the same measure. The same with the same measure. Not really a surprise there. So UV and ST are congruent because they have the same measure. Okay, they are congruent because they both have the measure of x. The arc addition postulate deals with all of these things, and so the measure of ABC, the arc, is equal to the measure of AB plus the measure of BC. It's like the segment addition postulate. Two things are right next to each other. To find the measure across both of them, you add them together. That's all there is to it. So that's the setup for arcs. So let's find out if we can do a little bit of operating with these arcs right now. Let's find the measure of CDE. Well, what do we know so far? So far, we know that AB is 18 degrees, and so we know that CD is 90 degrees, okay? So if we want to find CDE, we need to do a little bit of figuring. Well, we know that AB and ED both have, they're sharing chords, and so DE is equal to 18. So that's the measure of arc DE. And it must be 18 because it's a vertical angle. Vertical angles with AB. And so that's 18. So if we're going to find the measurement of this arc here, CDE, we know that this is 90 degrees and this is 18 degrees. Well, if we're going to find CDE, it's all the arcs that make it up together. So the measure of CD plus the measure of DE equals 90 plus 18 equals 108. So the measure of CDE, the arc, is equal to 108. Okay, that's pretty much all there is to it. Let's see if you can solve this one on your own, and I'm going to go ahead and give you this little hint right here. Okay, so see what you can do with that. A couple more theorems, 3 to be exact. Congruent central angles have congruent chords. So here I have the measure of angle CAB is congruent to, actually, measurements aren't congruent, measurements are equal. So the measurement of CAB is equal to the measure of angle EAD. So the conclusion that I can make is that DE is congruent to CB. Okay, so because these two angles are congruent, marked with the congruent sign, the chords that are between the endpoints of the angle must be congruent. Okay, next theorem. Congruent chords have congruent central angles. So here it shows me that ED is congruent to CB, and because ED and CB, it's the reverse of this top theorem, I can conclude that the measure of angle EAD is equal to the measure of angle CAB. Okay, that's what I can conclude. These are actually really useful theorems because then we can start to find the measurements of angles inside. Congruent arcs have congruent central angles. Here you can see in green, I don't know if it's obvious to you, so I'm going to mark it a little bit darker. Arc ED is congruent to arc CB. And so if the arcs are congruent, then the central angles are congruent. So by saying that ED is congruent to CB, I'm saying the measure of angle EAD is equal to the measure of angle CAB. So I'm saying the measurement of the angles is congruent, which makes the measurement of the chords congruent. Okay, so you see how these things are all related. This is a lot of background stuff. Okay, so hopefully you printed out these notes so you don't have to copy all these down. You can just write them in. Okay, so now let's apply this congruent arcs, chords, and angles. RS, this arc here, is congruent to TU. So let's find the measure of arc RS. Well, if these arcs are congruent, that means that 3x is equal to 2x plus 27. Well, when I solve this, I'll subtract 2x from both sides. I end up with x is equal to 27. And so when I solve for the measurement of this arc, I'm just simply going to plug it back in. And when I plug it back in, I end up with the measure of RS is equal to 3 times 27, which is equal to 81 degrees. So I can put that up here. And I know that this one must be 81 also. Next one. Two circles are congruent. And this go together. So AC is congruent to DF. Well, AC has a central angle of 5x or 5y plus 5. So I want to find the measure of angle DEF. Well, if I have DF, it has a central angle of DEF. What if I drew this circle here? I'll label this E, and this will be D, and this will be F. And the central angle measure here is 7y minus 43. I think that gives you a little bit better picture of what's going on. Well, if this angle, 5x or 5y plus 5 is equal to 7y minus 43, then I have an equation to solve, and I can go ahead and solve this. So I'll subtract 5y from this. So I end up with 5 equals 2y minus 43. Conveniently, this is subtracted, so I can just add it. I'm going to run out of space, so I'm going to scroll up just a little bit. 2y equals 48. So y is equal to 24. Well, that's not really what I want. What do I want? I want the measure of angle DEF. Well, DEF is 7y minus 43, so 7 times 24 minus 43. And when I do this, I get 140 plus 28 is 168 minus 43 equals 125 degrees. Okay? So that's 125 degrees. It's the same thing we've been doing, guys. We're setting pieces that are congruent, equal to one another, solving for the variables, and then go ahead and put those variables back in. Let's see if you can do these next two on your own. It's telling us something about bisecting here, and there's also something over here that looks a lot like what we just did. You also have another couple problems on this sheet that will be coming to you as an in-class addition. Okay, guys? Thanks for watching. We'll see you next time. Make sure you're taking those notes. Appreciate it.